Good evening. First of all, I would like to thank you, George, for this invitation to us. So I can start with a short video about us, about Stadata, and about Remuri. So who we are, what we did, what we have done, and what our software can do. Okay.
Stadata was founded in 1983 by Adriano Castagnone, civil and structural engineer since 1978, and pioneer of scientific software for structural engineering. The company was born to provide civil engineering services and consulting. We have always had a particular interest in the evolving sector of IT, foreseeing the enormous opportunity of applying it in design and computation. Before focusing on software development, Stadata realized important projects both with private and state-owned companies. That's our strength, because beside IT experts, we are professionals in structural design. The company is currently composed by 15 employees and several consultants, all highly professional qualified. Thanks to the continuous development of work and collaboration with the university and professional world, it is always able to offer advanced and constant updates to its customers. Application Stadata allows you to face everyday work with simplicity and effectiveness. The company goal does not end with the search of new IT solutions. The offer of Stadata includes support, training and consulting services, including individual projects so that the professionals are immediately operational. Thanks to the technical expertise and the state-of-the-art solution, Stadata is a solution to the real problems of designers. Remuri is the Masonry structures analysis specialized software. It is the leader in the world. It is used for existing and new buildings. The software performs nonlinear pushover analysis. The mesh is made with the FME method framed by macro element, specially studied for masonry structures to better represent the behavior of masonry structures. Now the software it is available in Italian, Greek, English, German, French and Albanian. And performs analysis according with Eurocode 6, Eurocode 8, Italian National Code, and the Switzerland National Code. Remuri takes origin from Professor Lagomarsino's academy research, and actually it is used for this purpose in more than 80 universities. Engineers and companies that use Remuri for professional purpose are widespread in more than 30 countries.
Okay, thank you. So now we are seeing what we have done till now, and this is what the future is coming. Because today we are going to speak about building information modeling, the new approach for modeling for structural engineering, but also for the whole procedure and whole process when we are to do something about constructions. So What we are talking about today is the approach that we have made for the Masonry structure itself. So we can talk about what is the process that can be done into a Masonry structure building. So first of all, we can start from the Ifc model, the BIM model produced by architectural softwares. And then we can start moving to smart planes. So creating plans of the software with the sections that includes all the information that are needed to create the Masonry structure. Masonry structure are, let me say, almost different from reinforced concrete, because when you look at a reinforced concrete structure, if you look at the architectonical model or you look to the structural model, yeah, they are quite similar in the geometry. So a column is always a column. But when you look at a Masonry structure, what you see in an architectural model is quite different from the structural part that you have to model it. Also because the behavior of the structure must be introduced into the structural model. So what we need now is the position of the walls, their thickness, their material, and the position of openings in order to create the correct mesh. And then we can create from this information the correct calculation model for a Masonry structure. And then at the end we can go back to through the Ifc models and then send the information back to the architectural procedure. So we can start having a look on how it can be done, this procedure, into our software Tremuri. Also in this case, we can starting opening our software Tremuri, so we can see what is the interface of the software. It's very simple because we're starting from a white paper, and then first of all we have to create what is the new model. So we can select the new one, giving the model name, and then first of all we can select what is the code that we are going to use. In this case, this is the Euro code, if the model is an existing one or a new one, and then we can select to OK. What we usually do is importing a DXF plan with almost every information that derives from a CAD software. What we are going to do now is importing the same plan, but from an IFC file, so the plan can start to be a smart plan. So we can open ourselves the BIM2CAD. This is a CAD that everybody knows. So you can draw lines, you have layers, you have view, you have all the things that you are used to do into a CAD software. But what we have more is the IFC possibility to import and export IFC files and to manage them, creating section and views and so on. So we can start from the menu, so importing an Ifc model. Okay, so it's loading the model. So this is a Masonry structure. It's a school in nearby Torino. And as you can see, it's made by column, beams, walls, roof slope, and so on. So something not so large, but with a lot of elements inside that can be transferred to the model into Tremuri. So what we can do here is creating smart sections. So we can now go to the IFC menu and select the procedure to create the section. So we can create horizontal and vertical section. At the moment, what we need is an horizontal section. So we can select the height of the section in order to create the right plan. So now we created the section on the first level. And then we directly save into the folder where we have created our Tremuri model. So we can find it easily when we come back to Tremuri. Software now creates the plans. Into these plans, we will see the axis of the wall, so we can easily know where we have to design them into the software. We can see the position of the openings and the thickness of the walls. These are the main information needed in order to create a model into Tremuri software, or better, a Masonry model for a structural analysis. So we can now go back to the software Tremuri and see how the import could work inside the software. Okay, so now we can start with a normal importing for the XF files. And then we will have all the information that comes from the Ifc module. Okay. Maybe it's coming. Oh, okay. So we select the import manager. This is the XF we have created into BIM2CAD. This is the scale of importation. So now we can start recreating the model into Tremuri with all the information that belongs from the Ifc model. So we can create easily the axis of our walls. These are the most important part, because this is the real structure that can generate the mesh into the software, because these axes are the reference for all the structural elements that will be designed into the structural model. So we can go on and recreate with simple snaps all these walls, and automatically the software creates into the intersection the corresponding nodes and all the structural reference that are needed. Okay. So into Tremuri, it's very important to create these axes in the right position, also for the Masonry analysis, because all the walls that are in the same axis will collaborate during the calculation. So this is an important part of modeling. It may seems that it could be easy, but it's easy because Tremuri is easy, but this is an important part of modeling, because all these axes will represent the direction in which the seismic action will be distributed into our numerical model. So now we can go through the structural part and select all the walls and assign them a material and initial thickness, just to create the model in 3D and having a view of it. So we have assigned the material and the thickness. Then we can split the view into the two windows, and so we can see what we have created in a 3D view and in plan. So now we are creating only walls that are structural, but only 2 centimeters thickness. And then we can also insert the real thickness of the walls with the added thickness tools. So only going through the walls with a line, the software recognizes the thickness imported by the Ifc module, and the walls are automatically created also into 3D view. So thickness and position, that are the main information imported by Ifc, are now used to create easily and in a very quick way the structural model. So the recognition is automatic. In these tools, you can also select a reduction of this thickness for the architectural part that should not be modeled into the structural model into Tremuri. Then, when we have finished to create all these walls, we can pass through, create all the openings. Also, in this case, we can use snaps and the positioning that comes from the Ifc file. So this is a view of what we have created. Now, with the two-point insertion, we can just easily snap to the structure, and the openings are created automatically in the plan and also in the 3D view. So we can always check what we are doing in the 3D view and also what we are doing easily in a plan inserting interface. So this is the main important part, because when we create the mesh, the position of the openings, the thickness of the walls, the materials, are the three most important information in a structural model for masonry and also for all other stuff. So now and then we have created this part, and this procedure can be easily used also to change the definition of some part of the structure. In this case, for example, here we don't have a wall, but steel beam. And so we still have the correspondence with with the snaps. So now we have created, in a very, very quick way, the first floor of our building. And then we can go on with the same procedure for all the other floors. Or if we have a regular structure, we can duplicate this floor and create all the other ones. Now we can open the model finished. That is the same one that we have created before. So this is the model after all the levels models. So it's very similar to the one that we are creating from the Ifc files. And so you can see that all the openings are here, all the elements are being made very, very quickly. And then we can finish our procedure passing through the creation on Ifc files of the structural model. So we can go back to our model and proceeding to something that is very easy because it's just like saving the model. We have to select the way we are going to save it. And so we made from export to FC, and we will create the Ifc model directly from the software. The Ifc is an open format, so then we can export it and share it with all the other engineers that use maybe other softwares. And for example, now we can check it with the Open Viewer Solibri, and this is the final Ifc export. So all members are here, so the Termori has exported the walls, exported the beams and columns with the materials, geometry, and positioning in the space. So this is what we are going to do for introduction to the BIM modeling, and what we suggest is the first step for the future method of producing computational modeling through the DIFC and through the sharing information between all the technicians that collaborates in the creation of a new building or in the retrofitting of the existing one. So, short presentation, but that's it. Okay?